Hello and welcome to Algebra 2. Today is Thursday, October 29th, and our topic for today is graphing radicals, where radical is just another way to say square root. A square root is a radical is a square root. They're totally interchangeable. But you're going to see the term radical a lot more often. Great. So the way we're going to approach this is we are going to build a radical function from scratch using an XY table. So we just want to start by graphing plain old square root x. We're going to make an XY table. So right off the bat, I know I can't plug in any negative values here because the square root of a negative is an imaginary number. So let's start at 0. We'll do these over here. Say f of 0 is square root 0 is 0. Okay, so and remember this makes the point 0, 0. Let's plug in 1. F of 1 is square root 1 is 1. And we'll do one last point. I want to pick a number that's easy to take the square root of. So let's try 4. Then f of 4 is 2. Actually, we're going to do one more point. Let's do 9, because that's also easy to take the square root of. You know, you could plug in 5, 6, 7, but you're going to get a messy decimal is the only problem there. So f of 9 is square root 9 is 3. Great, let's sketch this guy. Okay, so I've got 0, 0, 1, 1, 4, 2, and 9, 3. So you can see we get this kind of shape. I didn't draw it perfect, but you get the idea. And now this curve looks like it flattens out. It does not. It just increases very slowly. Okay, now that we know what the shape of the curve is, let's look at it with some changes. So pause whenever you need to write down the original problem. So here I have y equals square root x plus 5. A plus 5 off to the side here means it's going to shift us up 5. And when we're graphing these, we want to make sure to identify our vertex. So x is by itself. So what we do for the x values is we set this to 0. It's by itself. So x is just 0. And then the 5 off to the side there becomes our y value. So I know I'm starting at 0, 5, and then I have my general square root shape. And that's it for this one. Let's consider another example. I have two things going on here. So always I want to identify my vertex first. So I'm always going to take what's under the square root and set it equal to 0. X minus 4 equals 0. Add 4 to both sides. And the x value of my vertex is 4. And the y value says down 2. Negative 2, we always take this number literally since it's off to the side. So our vertex is 4, comma, negative 2. So 4, negative 2. And then I have my general square root shape. Great. One other thing I want to touch on briefly is if we put a negative in front of this square root, it causes it to open upside down. because all the y values become negative. So instead of 1, 1, it's 1, negative 1, so on and so forth. So let's consider the graph of y equals negative x plus 1 minus 2. As always, we want our vertex first. We're going to set the interior equal to 0. So the x value of the vertex is negative 1, and our y value is right here at negative 2. The other thing we notice is there's a negative up front. This causes the graph to reflect and open upside down. So I have negative 1, negative 2, and because of our negative out front, I'm going to open upside down. Alrighty. One last example, we're going to look at this multiple choice problem. It says, which of the following is the graph of square root x minus 2 minus 2? Before I even look at any of these graphs, I want to find the vertex. I'm going to set this x minus 2 equal to 0. And then this minus 2 is my y value. So my vertex is 2, negative 2. So right off the bat, we can eliminate any curve that does not have this vertex. Let's look at part A. Part A does have 2, negative 2. So we'll keep that for now. Let's look at B. Part B is negative 2, negative 2. We don't want that. Part C is the same. Nope. And part D is actually the same as well. So it must be answer choice A, because A is the only one with the correct vertex here. Alrighty, that's all for today, guys. Thanks.